Welcome, everyone. The name of this talk is Backup Best Practices with PG Backrest. We'll start with a short introduction and then talk about why and how to back up. What is PG Backrest? We'll discuss different types of backup types and retention. Then we'll move on to archiving and the importance thereof. We'll discuss recovery point objective and how to meet it. We'll discuss backups and recovery time objective and how to meet that. And finally, restore and recovery. My name is Дэвид Stili. I'm the principal architect at Crunchy Data. I've been actively developing with Postgres since 1999. I'm the primary maintainer of PG Backrest and PG Audit, and I'm also a Postgres contributor. So the first thing we need to talk about is why backup. There are a ton of reasons, really, and you probably know some of them, but I'm going to go ahead and go through the list because there are some you may not have thought of. The first one, of course, is hardware failure. No amount of redundancy can prevent this. So you really need to have backups of some kind to prevent losing your data when you lose your hardware. The next one is replication. Having a wall archive is great when your async streaming gets behind. And you can also sync a replica from a backup instead of from the primary, which reduces load on the primary. You can use backups to deal with corruption. Corruption can be caused by all kinds of issues, hardware or software. In this case, of course, the real challenge is detecting that you've had corruption in the first place. There's also accidents. Someone dropped a table, or a user accidentally deleted the most important account through the application interface. There's development, so there's no more realistic data than production. And so if you can use that in your development environment, that can be quite useful. This may not be practical, of course, due to size or privacy issues, but if it's an option for you, it's a good option. And the last one is reporting. So oftentimes reporting is done against production servers, but instead you can actually restore a backup and allow the reports to run from that restored backup if they don't need real-time data. For instance, if the report is starting from the previous day or the previous month or whatever. And the nice thing about that is you can also bring that up as a writable server so that you can create temp tables and do other things like that you might need to do your reporting. You can also recover data that was removed on purpose for reporting purposes. So let's say you're expiring out data from partitions or whatever. You can recover an older backup and get that data, or you can recover a backup and then restore that data from a PG dump. All kinds of options there, but all that can happen offline and reduce the load on your primary. So what you should really be doing in your environment is making your backups useful. A lot of people think of backup as something that's used in a disaster recovery scenario, but it's actually better if you can find ways to use your backups in your general enterprise, like, as I said before, syncing or creating new replicas. Offline reporting, offline data archiving, developing, etc. So the key here is that your backup and restore should be something that you're completely comfortable with and you're doing more or less on a daily basis. So that way, when it comes to the emergency, the restore that you're doing is just a normal procedure that you do all the time, and it's not something extraordinary that suddenly you need to go be looking up guides and figuring things out, and there's panic and sweating, and etc. So practice, of course, your disaster recovery scenarios, but also integrate your backups into your enterprise in a normal way so that you're completely comfortable with those procedures when it comes time to use them. So what is PG Backrest? PG Backrest is one of many backup solutions that are available for Postgres. It's easy to use, it's enterprise class, it can scale up to the absolute largest databases that you use. And we built it from the ground up to be designed just for doing database backup. Some of the major features are parallelism and asynchronous operation, full incremental and differential backups. Backup and archive expiration is automatically built in. There are tons of integrity checks, checks on verification. We have Delta Restore to make restores as fast as possible. We have S3 and Azure compatible object store support with GCS coming very soon. Encryption, we have multiple compression types, etc. Some of you may know that the original project was written in Perl, but we spent a couple of years migrating it to C, and that migration was finished in 2019. So there's still Perl in the project used for testing and documentation and stuff, but the binary that gets distributed is now pure C. So let's talk about backup types. There are 3 different backup types we support, and these are the pretty standard types of backup types that lots of backup software supports. Not all Postgres backup software does, though. The first type is full. Everyone should be familiar with this. This is just a complete copy of the database and is not dependent on any other backup. The next one is incremental, and in this case, we only copy the files that have changed since the last backup. And that last backup can be full, differential, or incremental. So an incremental can be based on the prior backup, can be anything. And then the last one we have is a differential. Now, a differential is really just like an incremental, but it's always based on the last full backup. And the big advantage of differentials is they can be expired independently. So if I create a full backup and then create differential 1 and then differential 2, if I like, I can expire differential 1 to save space, because differential 2 just depends on the full backup, never on differential 1. Whereas with an incremental backup, incremental 2 will depend on incremental 1, which depends on the full backup. And you can't delete anything in that chain, or of course you lose data. Now the incremental is the default because it's generally the least expensive backup type. If there is no full backup yet, then the incremental will automatically be switched to a full, if none is specified. So backup retention obviously is important. Backups are great, but they take up space and you can't keep them forever. So for me, I think a good default retention is 5. Assuming you're taking full backups once a week, this will give you 4 weeks of backups. Not everyone has enough space or money to do this, but this is sort of the ideal backup scenario. Some people go longer. I've seen backup retention as long as 2 years before. But for most people, 4 weeks is enough for disaster recovery. And then what I like to do is have 3 differential backups that are rolling. So we do a full backup on Sunday, and then we do differentials the other days of the week. And we've always got backups for the last 3 days to deal with the vast majority of disaster recovery scenarios. If we need to go back further than 3 days, that's fine. We have the full backups to support that, but there's going to be more wall replay, and the recovery is going to take longer. So that's always something to keep in mind when you're looking at the schedule, is how long is your recovery going to take, and how long can you afford to wait for that, which is something we're going to discuss in depth later. So with this retention, there'll always be at least 5 full backups, which means 4 weeks because we scheduled the full backups on Sundays. If the backups are run weekly, right, but if they're run weekly, there'll be 4 weeks of retention, but if they're run more frequently, then the retention will be reduced, because in this case, we're keeping 5 backups. But a safer option is to use time-based retention. So in this case, what we do is we tell how long we want the full backups to last. I've set this to 28 days here. So now when you run a full backup once a week, and differentials the other 6 days, there'll always be at least 4 weeks of backups. Now, if you take a full backup every day, then there'll be 28 full backups. But let's say you're taking them once a week and then you accidentally add in an extra one, then you don't have to worry about, you'll always have 4 weeks of retention in this case, even if you have an extra full backup. And if you want to, if there are extra unneeded backups because someone accidentally created one that you don't need, you can prune out those backups with ad hoc expiration. Note here that if the dependent backups will always be expired. So if I have a full backup and a couple differentials and maybe an incremental based on that, and I expire the full, all those differentials and incrementals will be expired at the same time. If you want to see what's going to happen there, use the dry run option. The dry run will not delete anything, but it will let you know exactly what backups are going to be affected by your expiration. So if you want to have a completely custom expiration scheme, retention scheme, you can actually combine the info command, which will give you a backup list in JSON format and when they were actually made. And then you can use ad hoc expiration to prune out the backups that you don't want. This, of course, is going to require some coding. You'll need to have some kind of scripting around that to make that work. Okay, archiving. So let's talk about archiving. Archiving is taking the wall segments that Postgres produces and offloading them to another server or another place. It could be S3, object store, it could be another server. But the idea is to preserve those, because if you want to do point-in-time recovery, that point-in-time recovery is the last backup plus the wall segments that are required to play forward to that point in time. So the way we do it is we do asynchronous parallel archiving, which you need to turn on, but that allows compression and transfer to be offloaded to another process and everything run in parallel, and it improves throughput significantly. You do need to make sure that there's enough space to hold the wall for an extended period if archiving stops. Let's say you've got some kind of network error, someone messes up the configuration, some other thing happens, the archiver starts failing, and that archive those wall segments will build up inside the PG wall directory on Postgres. And if you run out of space, Postgres is going to panic and stop. And that will be it. You will be corrupted in that case, but the database will go down, which is a very bad thing. So it's very important to monitor archiving. First of all, you need to have enough space to have an extended amount of time with archiving down, even though you don't want archiving to be down. And then you need to be monitoring it to make sure that archiving is working. All right, so now that we've got some of the basics there, let's talk about recovery point objectives. So a recovery point objective is the maximum acceptable amount of data loss measured in time. So let's say my recovery point objective is 15 minutes. That means it's acceptable for me to lose 15 minutes of data from my database after some kind of disaster or failover, etc. So we need to define our RPO. A lot of people will say, okay, well, my RPO is 0. I don't want to lose any data. And that's an acceptable answer, but you have to understand that there are going to be a lot of compromises you're going to have to make for that. For instance, the only way to really get to RPO 0 for sure is to use synchronous replication, which can have major performance impacts on your database, and especially if it's high latency, like you're talking between multiple data centers, or you've just got slow data links or whatever. And in certain situations, a 0 RPO may not be possible. So one of the scenarios we talked about earlier was the user accidentally drops a table from the database. If that change gets replicated to the standby, then you've got a situation where you have to restore from a backup and get to the point before that table was dropped. And so that may mean losing some data that was written after the table was dropped, or perhaps recovering that data from PG dump. There are lots of options, but the whole idea of absolutely 0 data loss in all situations is maybe not completely realistic. And when you're making your plans, you should be planning for what happens if there is some data loss. Because if you plan for 0 and then you get in a situation where you are going to have some data loss, you'll have no procedures in place to deal with that. So for a non-zero RPO, there are a couple of good options. One, of course, is the main one that people use is asynchronous replication. The problem with asynchronous replication is there's something called replication lag, where the replica is not able to keep up with what the primary is doing, either because the network is too slow to transfer all the wall files, or because the fact that the replica is doing recovery single-threaded is not enough to keep up with the multiprocessing on the primary. Various reasons here, but it's not uncommon to be generating enough transactions that the replica falls behind. So another thing you can do is use this value option in Postgres called archive timeout. And this ensures that a wall segment is archived at the interval specified. And as I said before, archiving in PG Backrest is extremely high performance. So we can keep up with data volumes that replication cannot. So your replica might fall behind, but at least you know that data is safely offloaded from the primary onto your backup server or object store or whatever. So if you get to the point where the primary goes away, you'll still have your data. You just need to wait for it to replay on the standby. So these two methods basically can also be combined, of course. In most scenarios, you're going to have both. Every disaster recovery scenario contains multiple parts. You're not relying on any one thing to help you. You've got replicas, you've got backups, You may have redundancy in your hardware. You've got all these things going on to give you multiple outs when something goes wrong. Another good practice is doing backup from standby. So backup from standby allows you to run a backup from one of your standby servers, which can greatly reduce load on the primary. Now, PG Backrest uses a slightly different technique than most software does. We have a hybrid technique that uses both the primary and a standby to make a backup. So the backup is started on the primary using the normal PG start backup command. And then we monitor the standby and when the replay location on the standby reaches that start backup location, then we can start copying from the standby. This reduces load on the primary because replicated files are copied from the standby. And then we pull a couple of files off of the primary that are needed, like configuration files. Anything basically that's not replicated that's in PG data will be copied from the primary. But usually that's an extremely small list of data. And so primarily everything goes from the standby. One of the reasons why we went with this method originally was that there are a couple of disadvantages to the typical way of backing up from standby. And one of the big ones is the standby is not able to rotate the last wall segment at the end of the backup. So you either have to wait for that wall segment to be rotated by the primary, or you have to just complete the backup without having that wall segment. And PG Backrest is pretty picky about making sure that all the wall segments that are required to make the backup consistent are present at the end of the backup. And if they're not there, the backup's going to fail. Because the fact is that backup really isn't any good with all those wall segments, and pretending that it is basically a bad idea. Another reason why we did it, and this is a possible future feature, is because of the way we've done this, we can actually do the copy from as many standbys as we want. So that could be parallelized across an entire fleet of standbys for a kind of extremely large database. But the primary benefit is just to get this load off of your primary. So another thing is to always remember to back up to a safe location. If you're doing your backups to a directory on the primary, this is really not a good idea, because the whole idea is you're trying to make your primary not a single point of failure. And if your primary database is there and your backups are there, then you may still have a replica. The replica might be behind, but the replica is only part of a disaster recovery solution. And if you lose your primary and your backups at the same time, you kind of lost two legs of your solution at the same time, which is not a good idea. So what you want to be doing is you can back up to a repository host, which we support. So you can have a remote repository host, which has whatever storage you like. You can use NFS. That's perfectly acceptable. Just have NFS mounted on the Postgres host, because that's still copying off the host. Perfectly fine. And then you can have that same NFS mount on the standby, and they're sharing the same storage. These days, it's increasingly popular to use an object store for backup. They're by definition off-site, unless you're running your own, but they're at least off the server. And if you're using something, from one of the big services, then your space is essentially unlimited, or at least as much as you're willing to pay for. The next thing you should be doing is enabling page checksums. Now, there are some performance considerations with page checksums. They cause something called write amplification. I don't want to go into the details here, but know that if you're running with page checksums, you are going to generate more wall, and there are going to be more writes. But my belief is that what you should do is start with page checksums, and only in the cases where they cause extraordinary pain should you back off on using page checksums. The good news is in newer versions of Postgres, you can turn off page checksums fairly easily, but you can't turn them back on easily. So that's the benefit of saying, well, we'll start with page checksums and we'll turn them off if we're not able to use them. So the nice thing here is that page checksums, basically what Postgres is doing is creating a small 16-bit checksum for each page, 8K page in the database. And so Backrest is actually able to read and verify these checksums while it's doing the backup. And it doesn't really add a lot of additional cost, because we have to copy all the data through memory to compress it and do all those things with it. So while we have the pages in memory, we're applying these checksums. We use the same code that Postgres uses to calculate the checksums. Literally, just copied the code. So it's as fast as Postgres does it. So the idea with page checksums is you can actually detect corruption basically I/O corruption, something on the disk. Hopefully this is not corruption that's caused by Postgres. If it is, then that's really bad. But what we're hoping here is this is if you lose a page on disk, especially in virtualized environments, etc., this seems to be more likely to happen. So Backrest will tell you when you get these bad checksums, and you can get this information through the info command. So if you do get corruption, don't panic. The whole idea of having multiple backups is you can use those to do recovery. And if the corruption was caused by some kind of I/O issue on disk, there's a good chance that restoring an older backup and performing recovery by replaying all the wall will actually get rid of that corruption. Before you do this, you're probably going to want to figure out what the source of the corruption was, or get on new storage or something like that. Another thing you can do is that sometimes it'll be the corruption is just in one area. So once you fix your I/O issue, you might be able to just go restore that table from an older backup. Let's say it's some kind of dimension table or something that doesn't change very often. If you can verify that it hasn't changed since X date, then you can go and retrieve that data and then load it back into the primary database. You can also do things like, if it's just an index, you can just rebuild the index. Again, after you've addressed the underlying I/O issue, you could just rebuild that index from the table and you're good to go. But the nice thing is Backrest is going to tell you when you have these conditions, otherwise you may not know, because you may not be hitting that part of the index on a regular basis. And until you do, Postgres isn't going to give you the error. So failed backups. Earlier I was talking about wall archiving and talking about how important it is to keep wall archiving working, as well as possible all the time. So backups are a little bit different because we have lots of different backups. So a failed backup should not be a big cause for panic. Ideally, there are a number of backups that can be used to restore, because remember, in the ideal retention scenario, we have 8. We'd have 5 full backups and 3 differentials. You may have fewer than that in your environment, but there's still going to be at least 4, 5, 6 backups that can be used. So it's the recoverable database that we're looking for is the backup plus the wall segments that were generated after that backup. So we restore the backup, we let it get to consistency, and then we replay the wall as far as we want. In many cases, people are just replaying wall to the very end, as much as is available. That's the standard scenario. You can say that, if you're trying to recover from a situation where a table was lost, you might be doing point-in-time recovery to an earlier point in time to recover that data. And at that point, as I said before, you have multiple options. You can either bring that database up as your primary and accept some data loss. If it's a data warehouse type situation, you may just be able to reload your data. Or what you can do is do that recovery on another system to right before the table was dropped, PG dump the data out of the table, and then restore that back into your primary. So there are a bunch of different scenarios that you can do here. They really depend on the type of database you have, your retention rules, etc. But mainly, the main thing is, so if your database starts archiving over the weekend, say on a Sunday morning or something, there's a good chance you're going to want to raise an alert on that and get someone to figure out why archiving is not working. Because not only you're not getting wall off-site, which is bad for your recovery point objective, but you could fill up the disk and Postgres will stop working. So that's also not really good. However, if a backup fails on a Sunday morning, everyone should keep sleeping, right? And this is an issue that maybe you can deal with on Monday morning. So if you're setting up your monitoring to look at backups, I would say maybe throw an error when you haven't seen a backup in 3 days, right? Because that'll give you the weekend to sleep in. And on Monday, you can figure out why your backups are failing, knowing that you still have a backup from Friday. So, it's really not the end of the world here. Now, the one disadvantage of working from an older backup, I should mention, is that recovery will take longer because there's more wall to replay. So depending on how big your database is and how much wall you generate, this could be minutes to hours to days, literally. The next thing to keep in mind is that if there are any gaps in the wall, like there's some corruption on disk or file is lost, or in object stores, sometimes files just go away, there are no guarantees, then you won't be able to play past that point. So ideally, you always want to be using a backup that's as new as possible. But in general, a backup that's 2 days old shouldn't be cause for panic in most scenarios. But it's up for you and your enterprise to decide, where the panic points are and what you absolutely need to require in monitoring. All right, so let's talk about recovery time objective. So remember, recovery point objective was the maximum amount of data that we would allow ourselves to lose during a recovery. And we talked about why RPO 0 can be tough, but something like RPO 15 minutes is generally a lot more reasonable and can be accommodated pretty well. Most people are going to try to find something in between those 2 points. 15 minutes sounds like a lot to a lot of people, and I agree personally. So recovery time objective is the amount of time it takes you to get to your RPO, right? So let's say our RPO at this point doesn't matter. It could be 0 or 15, but we need to know how long we can afford to be down, essentially. So we have some kind of disaster, there's some kind of failure, and then what's the period of time between then and when we resume normal operations? Is that 60 seconds? Is it 15 minutes? Is it 1 hour? And again, these things all depend on the enterprise and the database. If it's a data warehouse, which is feeding data to another system, there's a good chance that the RTO could be measured in hours, because as long as it's ready to load data into the transactional system by the next morning or whenever your data loads are occurring, then it's not a big emergency. And it might be that your data warehouse can just be failures there can be dealt with during the day, and they don't have to be dealt with in the middle of the night. But so when you think about recovery time objective, just like recovery point objective, you need to be thinking on it really on a per database/application basis. To apply RPO, RTO across an entire enterprise is almost certainly a mistake, because different databases have different requirements, different applications that are using those databases have different requirements, and you need to keep all that in mind when you are making these rules. So how do we meet the recovery time objective? Well, the first thing, of course, is you have to define it. We were just talking about that. The easiest way to meet a low RTO is to have a standby server ready, and then fail over to that from the primary. This can be done manually or with a tool that automates the process like Patroni. Automating the process of failover is becoming increasingly more common. And you do need to think about the tools that you're using, because Patroni has a bias towards uptime by default. So it's going to, if you have multiple standbys, it's going to pick the standby that is most up to date, and it's going to promote that within some period of time. And it's not going, by definition, it's not going to care that much about how far that standby might be behind. So if it's 30 seconds behind, maybe that's not a big issue for you, but if it's 30 minutes behind, that might be an issue. And if it's 30 days behind, well, now you've got a real problem. So in this situation, just like we were monitoring the archiving to make sure we've got archive off system, we need to monitor the standby to make sure replication lag is within our tolerances. So if the replication lag exceeds our RPO, we need to have alerts for that and know that's happening. In fact, you should be doing something like alerting when the replication lag has gotten to maybe 50% of your RPO, right? That way you have a chance to do something about it, hopefully, before you actually exceed your RPO, because if you have a disaster right at that point, you're not going to meet your RPO. Whereas in this case, you're almost certain to meet your RTO, because failover it's not instantaneous, but it's quite quick. So this can't be said enough. A standby is not a backup, okay? So a standby is part of a disaster recovery solution, and we see here it's great because if we have a failure on the primary, in this case we're talking about hardware failure, system crash, networking failure, the thing gets isolated somehow and no one can talk to it anymore, who knows? So in that case, the standby is your go-to solution, because the standby has a copy of all the data that was on the primary up to a certain point, hopefully up to your RPO, and then you can just fail over to it and you're good to go. And then you can go figure out what happened to that primary. Now, hopefully you have another standby to take over if things go wrong then, but if not, you should have a little bit of breathing room. But there are other types of things that can happen that standbys are not good for. And what the classic scenario that we were talking about is something gets dropped or deleted on the primary. You can have delayed replication, which obviously affects RPO, and some people will do that. But in general, you need to be prepared for the scenario where something gets deleted off the primary and gets replicated to the standby. And in that case, the standby is not going to help you because that data is now gone. So you need backups to cover that scenario. As I said before, there are all kinds of other things you can use backups for. So you shouldn't think of backups are only for the use in this one scenario where the standby data is deleted or the standby fails or whatever. There's all kinds of things you can use backup for in your daily enterprise, and you should be thinking along those lines. So daily backups are usually sufficient to meet your RTO requirements, but you need to measure, right? So like I said before, if you recover a backup and then you replay WAL, that's going to take a certain amount of time. The restore itself takes a certain amount of time, and then the recovery takes another period of time. Let me define those a little more specifically. The restore is what PG Backrest does, and that is the action of taking the files from the repository and copying them back into the PG data directory. And PG Backrest can do this very efficiently because of the Delta restore capability. We have checksums of all the files that are in the repo. We can compare those to the checksums of the files on disk and only restore what's needed. So Delta restore can be extremely fast, even for a large database. It just depends on your rate of change. So the rate of change is what affects the restore time. If you're restoring to a system that already has data, if it's a completely new system, then you're going to have to restore everything, of course. Recovery time is what Postgres does once the PG Backrest has done its job. It's copied the files back. It's set up the restore command. Now Postgres is going to replay all those WAL files on top of that backup to get you first to consistency and then to whatever your recovery time, whether it's the end of the WAL or whatever. So you need to do tests and measure that restore and recovery time so you know how much that is and make sure that it actually meets your RTO. You can't always depend on having a standby around for RTO. That's the lesson here. So you also need to measure what it takes for you to basically restore cold from a full backup, restore an entire backup and do all the recovery from your last backup, which I generally recommend to be daily. So this is something I've been putting in my slides for a long time, but this is true. The state of any backup is unknown until a restore is attempted. So you need to be doing restores on your backups. And if you just are running the backup solution and hoping everything's going to work and you do a restore, you might be disappointed. PG Backrest has tons and tons of stuff built in to tell you when backups are not working correctly. But it's possible for those to be disabled. It's possible for those warnings to be ignored. Not everyone monitors their logs as well as they should. So you should proactively be testing your backups to make sure that they actually work. So like I said, multiprocessing can lead to dramatic reductions in restore time. But your network bandwidth is still going to be an issue. Delta restore can save time. Also, when you're doing recovery, double check where you're restoring. Backrest will refuse to overwrite a running cluster, but it will overwrite a shutdown cluster if Delta's used. So if you've got like let's say an old primary that you're going to recreate as a standby, but well, wait a minute, you don't want to overwrite the data that's already there initially, right? You want to keep that data because maybe you want to do some forensics on it, or maybe you're hoping to recover some data from it, or you're just a case. If you take Backrest with the default configuration, which was in whatever PG data directory you had specified, and you do a Delta restore, it's going to make that primary look just like the last backup, and all that data will be lost. So my preference is to, in a situation like that, to leave that old database alone and bring a new node into the cluster to be the new standby. And that gives you some leisure to go look at that old primary and decide whether there's any data you need off of it. Maybe you need to do some forensics work to find out why that primary went down in the first place. It may not be clear. It could have been a software issue, hardware issue. Maybe the storage dropped offline. There's all kinds of things that can happen. And if you know what happened, that can help inform you to make sure that doesn't happen again in the future. So you need to do the restores to find out how long they're going to take, right? That's step number one. But then you need to test your restores. So what does that mean? We need to validate that the database looks correct after the restore. So there are a couple of things we can do here. First of all, if we're doing some kind of automated restore testing, which I recommend and a lot of companies do, you need to make sure that your RPO is met. And one of the easiest ways to do that is to check timestamps in the database. So everything, Postgres is going to have all the transactions up to a certain point, and then nothing after. So it's not going to really cherry pick. Now, if you have a really long running transaction, that one may not commit, whereas some smaller transactions will commit. But one thing you can do is you can actually just check the timestamps. So if you've got some kind of logging table, you can look at the timestamps in that table to make sure that you're keeping up to date on that table. And that's a pretty good indication that your RPO is met. RTO is easy to measure because you're just looking at the amount of time it took you to restore and recover. But RPO needs to be measured as well because it may not be clear that the database is only 15 minutes old rather than 30 minutes old unless you have some timestamps to help you verify that. One thing you can do in this case is just have some kind of heartbeat. If you really want this to be accurate, you can have a process that is just literally updating the timestamp in a table or logging to some table on an extremely regular basis. So you know for sure that you're getting new data, your restore has that new data in it. Because if your database has less traffic, it may not be exactly obvious to you that the restore is older because all the timestamps are old, and that's normal because it only gets updated once every 6 hours or something like that. But it could be updated more frequently, and you wouldn't know, and you would be losing that data. Another thing you can do is use tools such as AmCheck to verify the consistency of the cluster. So what this tool does is it goes through and it looks at the logical consistency of the database. So it's making sure that the indexes actually match the tables, et cetera, et cetera. So this is something that you can't really tell from just checksums. Because the pages may all checksum correctly, but there may be some logical inconsistency in the database. This can happen because of bugs in Postgres. It could happen if a file was copied over or swapped or something by a user. All the checksums in that file would verify correctly, but the file would no longer logically match the other files in the table. So if that file was an index and you copied it over with some older copy of the index or something like that, these files are no longer going to match. Like I said before, in some cases, when you find corruption like this, you can just rebuild the index. But if the issue is you find is that there are primary keys in the table that shouldn't be there, and don't match your foreign key constraints, then you've got some more cleanup ahead of you. Another thing you do, which is fairly simple, is run a PG dump, and if possible, restore the cluster from that dump. And that'll let you know whether all your primary keys and foreign key relationships and all that stuff are good. This may not be possible if your database is particularly large, but at least I would recommend doing the PG dump because it'll let you know that all the heap tables the tables can be read at least, even if there are problems in the indexes. And the last thing that you can do is most organizations have some kind of smoke test or regression tests that they are running when when they, let's say you're upgrading your application, you do the upgrade to the database, and then you run these smoke tests. Well, you can run those same smoke tests after a restore. And that will just generally let you know that everything's there. It may let you know if data is missing, like say data and dimension tables that should be there, and now your tests don't run anymore because that data is missing, et cetera, et cetera. So if you have smoke tests or regression tests, that's a great thing to do here. And the nice thing is you don't have to worry about them being destructive because you've restored this copy of the database to do testing on. You bring it up as a writable cluster, and then you can go do what you want against it. And when you're done, you're actually going to throw away that result. So it doesn't matter what changes you might make to the database. So you might have tests that are even more destructive than your regular smoke or regression tests to adequately test this database. So in conclusion, you really need to make a disaster recovery plan. This is extremely important. You can't be winging it on the day of the disaster. You can't anticipate everything, of course, but you can, most database people have a fair amount of experience with, these are the things that have happened to me in the past. This is what I need to be looking out for. The next thing you need to do is document the disaster recovery plan. It's not enough just to have a meeting and talk about it. You need to write it down to make sure you know that everyone's on the same page and you've covered all your bases. And then the last thing is, we were just talking about, you need to practice that disaster recovery plan. The great thing is these days, there are all kinds of good virtualized environments you can use to make sure that you're, set up a bunch of servers, try all kinds of different scenarios, bring down the primary, bring down the network, fill up the disk, all these sorts of things, and you can try them and see what happens and practice how you would recover from those. All right, thank you very much. That's all I have. Are there any questions?
First of all, what about wall archiving? Some guy is asking about how can you show an example or describe maybe some example of settings for correct wall archiving?
Okay, well, that's going to be a little hard to do here on video, but what you can do is
maybe just give some ideas.
Yeah, if you go to the PG Backrest homepage, actually, which is on that last slide, pgbackrest.org, in the user guide, which we provide for Debian and RHEL, in the Quick Start section, there will be a section called Configuring Archiving, and it actually goes through all the settings that you need for configuring archiving in the settings in Postgres.conf, like archive mode, archive command, wall level. And so those settings are actually set out there, and so that's the best place to go. There are also plenty of tutorials for PG Backrest written by many people like Stefan Foucault, for instance, etc. So one of those would be good. I'd be happy to get on the chat in a little while and paste in some specific URLs if that would help.
So if you have, for example, if you have given some PTO, for example, 10 minutes, what should be should you have some special settings for wall archiving?
Yeah,
so it doesn't depend on PTO.
The main setting that I would set in that case is the archive timeout setting in Postgres to make sure that Postgres is going to create and archive a wall segment every 10 minutes, right? So that way, if your replica falls behind, you get some kind of lag there, you know that every 10 minutes you're going to have a wall segment archived, and that will help you meet your RPO. Now, in that case, though, you do need to be monitoring the archiving to make sure archiving is actually working and is up to date. So that part will be very important when you're using archive timeout for that purpose. Monitoring is always key.
Okay, so next question about the streaming protocol. Are there any plans to add support of streaming protocol for PG Backrest?
Yes. One of the reasons why we haven't done this yet is that the streaming wall is actually quite slow, unfortunately, because it's uncompressed, you're transferring it to another machine, etc. So what we've been planning to do is some kind of hybrid scheme where we're using the streaming protocol to stay as up-to-date as possible, but we're also in the background using our normal method with archive command to archive wall quickly. So that way, if you get a big inrush of wall, we can not get too far behind because we'll be using our normal method there, and then we use the streaming protocol when things are a little quieter, just to keep the wall as up-to-date as possible. There are some challenges here dealing with object stores because a lot of our users use Azure S3. We're just introducing GCS in a couple of weeks, and so having partial rights to object stores is not necessarily all that easy. So we need to figure out how we're going to handle that, and maybe it'll be certain thresholds. Maybe we'll, we haven't quite worked out how we're going to do that, but it is in the plans.
Yes, it's an interesting problem, really, how to stream to object storage. Maybe you need to have some intermediate storage for
yeah, that's probably what we're going to do.
For accumulating the walls. Yeah.
Yeah. Then you have to worry about what happens if something happens to that intermediate storage.
Yeah, of course.
And how much wall are you going to lose based on your desired RPO? So maybe Backrest has to be aware of your RPO in order to make that determination of what to keep in intermediate storage and what to move off to the object store.
Okay, next question is what about restoring only one broken database in a Postgres cluster? For example, a cluster may contain many databases, you see, but for example, you have deleted one data directory inside the cluster, and you want to recover one database.
So we do have a feature for this, which is talked about in the user guide. We call it selective restore. And so you're able to restore a single database out of a cluster with some caveats. So the wall replay for the other databases still has to occur currently because we're not filtering the wall. So what happens is we restore the databases that you want. We restore all the other databases as sparse zero files, so they don't take up a lot of space. And then we perform wall replay. We also make sure that those other databases can't be logged onto. So if you try to log onto it, you'll get an error. And the only valid operation for those other databases is dropping them. But that's essentially how we handle restoring a single database out of a cluster.
Okay, thank you. Next one. So how can we restore the backup to another instance? So probably other, not this instance when it was taken, probably.
Well, the essentially the way you want to do that is set up that other host with the same configuration you have on the primary, pointing at the repo, all that kind of stuff, and then you do a restore. And before you actually start Postgres, you'll want to turn off archive mode, or there's an option in PG Backrest to do that. Because if you're not bringing this up as a new primary, you don't want it pushing wall into the repository. But there are instructions for this in the replication section in the user guide. So that shows you how to restore to a new host and set it up as a replica. Now, in those instructions, we're assuming that that's a replica that might get promoted to a primary at some time, so the configuration is identical to the primary. But as I said, in the case that you don't want to create a new primary, you'll want to turn off archive mode using either the PG Backrest option or editing for whatever. That's pretty important because you can end up polluting the repository with a new timeline if you don't do that.
Okay, so is it possible to start simultaneously backup process for several clusters on the same host? Will it be okay for PG Backrest?
Yes. So you can start up as many backups as you want on the backup host, but you can only each cluster can only have one backup running against it at a time. So we do have a limitation there just to make sure. A lot of this has to do with older versions of Postgres where if a backup wasn't stopped, it kind of got stuck in a state and you'd have to go stop it in order to continue. But in general, we feel that you shouldn't really be doing more than one backup against one cluster at one time. But if you're backing up different clusters, no problem. You can run as many simultaneously as you like.
So is PG Backrest protected from simultaneous running on a single cluster by two instances of PG Backrest?
Yes, we do that two ways. We take a lock on the actual database host. So we have a lock file on the database host. And on top of that, we have an advisory lock in the Postgres cluster itself, just in case there's some naming conflict or something like that. So we have two ways that we check to make sure that you're not running simultaneous backups against the same cluster.
Okay, thank you. Next question. Do you have experience of backing up very large databases, dozens of terabytes?
Yeah,
are there any troubles from the long time of backup?
There are always troubles. So the biggest databases that I currently know of that are being backed up are hundreds of terabytes. There's a PG Backrest out of the gate is set up with gzip, compressed level 6, etc., which is possibly the worst compression you can use. But everyone has it. Gzip is everywhere, and it's the original default, so it's still the default. So if you're doing really, really large clusters, you're going to have to make sure you have a lot of bandwidth. 1 gigabit network is not going to do it. You need 10, 40, 100. You'll also need a lot of cores to do the compression. and you're going to need to be selective about your compression algorithms. So you can use LZ4, which is extremely fast but doesn't really compress as well. You can use Z standard, which can be tuned to be extremely fast. You're not going to want to use gzip or bzip for those extremely large databases. And then the other thing is to, scheduling obviously is important. You don't want to run the backup too hard. But in general, PG Backrest will keep up with whatever the hardware can do. So if you have the I/O and the CPU and the network bandwidth to do those backups, then you'll be able to do those backups. There are some instances where people are using PG Backrest to do backup and then restore to the replica in a cycle because streaming replication can't keep up. So they got these very large databases, they do incremental backups of it, and then they restore those, and then they keep that cycle going to keep their RPO down to an acceptable level. In this case, RPO is generally measured in hours.
I see. Okay, go next. Two questions in one, or one and two. Are there any mechanism to take parallel backups and to restore in multiple streams?
Yes, so backup can be run in parallel. There's a setting called process max, and you just set process max to whatever you want. The upper limit on that right now is set to 999. It used to be 99, but there was someone who wanted to do 196, had 196 cores, and they wanted to do a backup that big, so we had to bump up the limit. And restore is the same way. So restore, you can set process max, and generally speaking for restore, you set it higher because the system's quiet during a restore normally. Normally the database is not running if you only have one cluster on the system, so you can restore as many as you want in parallel. And we also do a delta restore where we checksum the local files and see what's changed. And we only pull from the repo what you need. So even for a very large database, if the rate of change is relatively small, your delta restores can be extremely, parallel delta restores can be extremely fast.